Hi there. Thanks for Kids on Team Andromeda, Nova Star, and Sirius for tuning in. We're going to be using our new skills with multiplying polynomials. Sorry, I got a cat there who I'm trying to, my kitty cat keeps moving my camera. Sorry. We'll be working together to solve more complex equations. So you can see here's our first one. My thoughts are we'll do this one. You can watch or you can record with me. And then I'm hoping for the second one, you give it a try by pausing it once I give it to you and then watching what I did. So here I have the quantity of x plus 3 times the quantity of x plus 4. We got two binomials being multiplied. Those are considered polynomials, equals x squared plus 3 times the quantity of x minus 5. So anytime you have a more complex equation like this, we are going to begin by simplifying this. And I shouldn't say expression. I definitely should call this an equation because we have a equal sign. All right, so let's begin by doing that. So off to the side here, I made that generic rectangle for our binomials to be multiplied, that x plus 3 and that x plus 4. You could also try the FOIL method if you want. But either technique, and I'll kind of go with the FOIL method here, since it is something new that we're trying. If I do employ the FOIL method, I am going to get here x squared. Here I'll get 3x, and then x times 4 gives me plus 7x. And then the last 3 times 4 gives me 12. All of this equals x squared. And then I'm going to distribute that 3 to get plus 3x. And can't forget that minus sign, minus 15. So now take a look at our more complex equation. What do you think makes this equation more complex? Hopefully you're thinking about, well, we've really never seen x squared in an equation. We've seen them in expressions, but we haven't seen them in an equation. So we're going to start by getting rid of and subtracting those x squareds from each side. So let's start there. That will make our lives much easier. Now, at some point this year, later on, we will deal with solving equations that actually have x squareds in them and they can't be taken away like I'm going to do here. I'm going to subtract the x squareds from both sides. I like to cross those off to show they're gone, to arrive with an equation of 7x plus 12 equals 3x minus 15. And one of my philosophies, many of you have heard me say, and if you're not my students, well, I like to say, well, which x should I get rid of? I want to keep things positive in equations like in life. So I want to get rid of the smaller one to try to, if I can, keep things positive in this equation. So as you can see, I've decided to subtract the 3x from both sides. And then what's our new equation here? 4x plus 12 equals, don't forget that minus sign. Sometimes kids do, and this would be considered a negative 15. So we're trying to get that x alone. So picking a different color here, I am going to get rid of my 12 that's being added to subtract 12 from both sides. So I'm going to get 4x equals a negative 27, and then divide both sides by 4 to undo the multiplication. And I'm going to do some work in my head here. 4 goes into a 27 3 times. I got to remember it's negative, or excuse me, 4 goes into negative 27 6 times. I was thinking our remainder is 3. So here I'm going to get x equals negative 6 3/4. You can check it on a calculator, and that would give you the decimal equivalent of negative 6.75. So that was our first equation. Take a moment, look over it, think about what we did here. We subtracted the x squareds from both sides so that we were then able to solve our equation just for x. Okay, if you need another moment, pause, review my work, or add it into your notes if you'd like to do that. All right, guys and gals, so here is equation number 2 that I hope you will try now that you see me do one of these. Feel free to work with a partner or talk within your breakout room. And here we have 6 plus x times the quantity of x plus 1 equals the quantity of x minus 6 times the quantity of x plus 9. 2 binomials here, so those are our polynomials. And feel free to pause right now so you can take a moment, do the work, and then unpause to see if what you did agrees with what I did. So feel free to take a pause right now. All right. So here I started out by making a generic rectangle with my x minus 6 and my x plus 9 here. As you can see, here's my work. That helped me to get x squared plus 3x minus 54 on this right side. And I distributed the x here. If you remember the distributive property, we have that right up here where we're distributing this x to both terms in the parentheses. And then, like we did in the first equation, we want to subtract the x squared from both sides to get 6 plus 1x equals 3x minus 54. I subtract the 1x from both sides to get rid of the smaller x, keeping it positive, like I mentioned in the first problem. And then here you can see my last couple steps to get the x alone. I've added 54 to both sides. Love it. I was able to keep things positive, and 60 equals 2x. Most of you probably logically know, well, I must be multiplying 2 times 30, or you can divide both sides by 2 to get x equals 30. And thank you for tuning into my video. Hopefully you're getting better at solving equations and now seeing how you can have equations which also has multiplying of polynomials in them. Thanks for tuning in. Hope you have understood this, and take care.